In 3.2, logarithmic functions, we're going to talk about how to work with logs and solving for exponents, basically. So let's talk about the basic concept. Logarithmic form, or also known as log form, is basically log with the base b of x equal to y. Now, b is our base, and then y is our exponent. So sometimes you might be looking for just what's inside the parenthesis or what's next to log b, or sometimes you might be solving for the exponent. Now, in order to do that, here we're going to talk about the relationship with exponential form. Now, the reason we call it exponential form is because the variable is being used as the exponent. So, to go from log base b of x equal to y, now keep in mind, it won't always be just x, and nor won't be always just be y. This is just variables in place of it. So sometimes it might be a, m, and sometimes this over here could be like c or r or s. So keep in mind that whatever log base b of x, whatever it equals to is the exponent. And then whatever we have in here, it could be a number or it could be another variable. Now, to convert from log form to exponential form, you rewrite it where whatever base you have, you write it as the base, and then you raise it to the exponent that is equal to. So whatever the log equals to, that's your exponent, you raise it to that exponent, and then set it equal to what over here is next to your log. So again, from log form to exponential form, what your base is, you're going to write it as the base, and then what the log equal to, you're going to raise it to that exponent, and then in your exponential form, you set it equal to what was next to your log. So again, my base b raised to the power of y, set it equal to x. So, when dealing with this, or using this concept, we're going to use it for evaluating logarithm, or logs. So our first example is log base 3 of 81 equal to x. So here are the 3 steps on how to evaluate logs. Our first step is writing in exponential form. So we're going to write this in exponential form. Now the reason about these 2 arrows is because you can go from log form to exponential form, and the same thing can be in reverse order. You can go from exponential form to log form. There's a direct relationship with them, so they can go in any order wherever you start. So I'm going to write in exponential form. So this is our base right here, our subscript number. So I'm going to write 3, and then whatever it equals to, which is x, that's our exponent. And then I set our exponential form 3 to the power of x equal to whatever was next to log base, which is 81. So now we have our exponential form 3 to the power of x equals 81. Step 2, convert into same base. So that means that we need to convert where on both sides it has the same base. So over here, it's base of 3 to the power of x. So I don't have to do anything now because this is a simple base. I can convert into a lower base. So on the left side, it's 3 to the power of x. Now 81, we can convert into a common base. So let me rewrite the left side. Now the common base would be 3, and then 3 to what power would become 81? Well, that's 4. So 3 to the 4th power is 81. So all we did was change 81 into a common lower base. Now keep in mind, common or same base, it has to be the same on both sides in order to solve for the exponents. So all I did was change 81 to a lower base with an exponent. Now, once you have same base on both sides, our last step is solve for exponent. So again, if it's the same base on both sides, then all I had to do is bring out the exponent. And there we go. Our exponent is 4. So, log base 3 of 81 equals to 4. So that's all we have to do. Now, you can rewrite this to get used with log form. But when you're evaluating logs, this right here is good enough. Now, but you must specify that the exponent equals to the number. When it comes to evaluating logs, so we have to memorize the bases and their exponents with their corresponding answer. So we already know that 2 to the second power is 4, but let me explain about it. So 2 is our base raised to the second power, meaning that the base will time itself 2 times, so 2 2's. And then you have 2 times 2 is 4. Now let's talk about 2 to the third power. So its base, 2, will time itself 3 times. So there's 3 2's. 2 times 2 times 2. Now, all we have to do basically is start from left to right. So 2 times 2 is 4, and then 4 times 2 is 8. So let's talk about 2 to the fourth power. So 2 to the fourth power means that the base will time itself 4 times. So 1, 2, 3, 4. Now, we're going to start from the left. So 2 times 2 is 4. 4 times 2 is 8. And then 8 times 2 is 16. So, it's going to be like a lot of writing, a lot of working out, memorizing. But there's a faster way. We already know that 2 2's, so 2 times 2 is 4, based on what we have here, but also based on how we did it before in the previous math classes. Now, in algebra 2, you learn that if you have 3 2's multiplying to each other, it's automatically 8. So instead of just like going one by one, you can do is, oh, I remember that 3 2's make an 8. So then 8 times 2 is 16. Now keep in mind, be very careful, like they're all multiplying. So when I say 3 2's, I'm emphasizing or implying that they are multiplying to each other, not adding, not subtracting, not dividing. 3 2's multiplied to each other is 8, and then 8 times 2 is 16. So that would be like a faster way. Now usually, for me, I would memorize most of this, and I highly recommend that y'all do the same. So you have to first write it down, memorize it. So this is the basics what we're going to be using for evaluating logs. Now, I wrote out most of it by memory, but the easier way you can do is here, 2 to the fourth power, which we did, is 16. If we look at the pattern, we see that 4 changes to 8 by 2, meaning times 2. And then 8 changes to 16 by multiplying by 2. So, if you were to like start from the basics, or start off with say 2 to the fifth power, but you don't know what it is, well, let's see. If I remember that 2 to the third power is 8, if I want to go 2 to the fourth power, I'm going to multiply by 2, get 16. And if I want to reach to 2 to the fifth power, I'm just going to multiply by the same base, which is times 2, and get 32. Now over here, let's talk about base of 3. So we know that 3 squared is 9. If I want to get to 3 to the third power, I can just simply multiply 9 by the base, which is 3, and that's 27. Now if I want to go to the fourth power and say, hey, I know what 3 to the third power is, it's 27. I'll multiply by the same base times 3, and that's going to get 81. But if I'm looking for 3 to the fifth power, and I don't know what 3 to the fourth, but I do know what 3 to the third power is. So okay, I'm going to start with 3 to the third power, and then multiply by the base, which is now 3 to the fourth, and then got 81. But I'm needing to go to 3 to the fifth power. So I'm going to multiply by the same base again, so 81 times 3, and then that's going to give you 243. So that's what you can do to save yourself some time. But usually what I recommend is write out all this information, and then memorize it. But I highly recommend to memorize up to the 4th power. To the 5th power, you can simply just multiply whatever you have in the 4th power by its base. So for example, I know that 4 to the 4th power is 256. But if I need to look for 4 to the 5th power, all I have to do is just simply multiply 256 by its base. So 256 times 4 would be 1024. So now I know that 4 to the 5th power is 1024. And then I could do the same thing with the 5th base. So say I remember that 5 to the 4th power is 625, but I need 5 to the 5th power. So I'm going to start off with 5 to the 4th, which is 625, multiplied by the base 5. So 625 times 5 will give us 3,125. So now I know that 5 to the 5th power is 3,125. So again, best to write this down and memorize it when it comes to evaluating logs.